This talk is going to be on a subject that is very dear to me, so hopefully you'll enjoy it as well. Some of the code snippets that you'll be seeing here are React stuff, but don't worry if you're not a React guy, a React person. The concepts that I'll be talking about are transversable. And by the way, at the end of the talk, I'm going to do a small quiz to give away a copy of this thing here, which is something that I may have not written. So let's see. Okay, so this talk is about state management. And, well, I like to say that state is the heart of your application. Really, I challenge you to try to build an application without state. You probably could for a bit, but then like 30 minutes after, you'd start ripping your hair and stuff like saying, why the heck did I do it? Well, the first one would be to prove me wrong, but, well, that's a completely different thing. State is a very important thing. It's the art of your applications. And just to think about it, just look at all the ways that we can have to manage it. There's a lot of state management solutions. It's like opinions. Each one has their own. Now, one thing that might come to mind is, what the heck is state? Okay, if we have this thing, what is it? Well, state is often defined as the mutable data source that you can be used to store data relevant to your application. This data can change over time and can be used to influence how your component will render. Now, in the React ecosystem, there's two native ways that you can handle state. If you're a React developer, you're definitely familiar with them. We have the useState hook, pretty simple, a value and a setter. Then we needed to start having more complexity a bit, so we started having a reuse reducer. Now, pattern is a bit different, but okay, we have actions. We dispatch an action, and this thing will change its state. Well, I don't use this a lot, but it is what it is. And then we started to have a need to share this state, because this state was in its component, but we need to share it between components. So what's the native thing that we can use to share state between components? Oh, sorry, timeout. There was a need to share state between components. So what's the thing that you have in React that you can use to share state between components? Anyone wants to answer that? Exactly. So some of you already gave me the answer. It was context. That's what we started doing. Now we have our use state or use reducers or whatever in context, and we can use it to share state between components. Now, soon we started having some other issues, namely two. The first one was we started putting everything into context, and we had unrelated logic grouped together in the same thing, so that was a nonsense to manage. And the second one was that a lot of people say, oh, now we have a lot of unnecessary re-renders. Heck, you might care about that, you might not care about that. It depends if you're a performance freak, if you worry about it. Re-rendering is something that it's important, but that's not the point here. The reason why we started to need context was to have something that you can use to share state between components. Now, when this thing and this pattern starting to being a bit of a nonsense, we went back to the solutions. Heck, some of us even skipped the native stuff and went straight to Redux because that was the thing that everyone was using, or any other solutions. The point here, and I think I already said this previously, state management solutions are a preference. You might like Redux, you might like ZooStand, heck, you might like Recoil, whatever, MobX. It's a personal preference, each one has their own. And they exist to do something. What they exist to do is to manage state. It's a state that is shared between components. Often what happens with this state is that we call it something. We call it global state. It's the state that it exists somewhere over the tree, everyone can access it. But there's one issue with global state. And the issue is global state is a container. It's a container that exists to manage different types of state. And each type of state has different challenges. The main types that we often hear is client state and server state. And we have been using these tools. We've been using these tools that were built and created for client state. But the challenges that they solve are not the same ones that server state solve. And because we have been using these tools so far, we have been putting everything into this container that's global state. Well, first we might be misusing our tools. And then therefore, if we are misusing stuff, we might be wasting our time. And what happens? If we waste our time, we're wasting our money. So we're going to talk about some things in this talk that will hopefully change the way that we look at state, introduce you to something that I really like to manage, server state, which you might have already been spoiled if you see me showing the book. But yeah, the title of this talk is You Don't Know Server State Yet. Hopefully, by the end of this talk, you will, and we'll know a bit more about how to manage it. Just to introduce myself, after being here talking for like 5 minutes, I'm Daniel Afonso. I'm working as a developer advocate at OLX. I came all the way from Portugal. I'm an Aged.io instructor, an Altira ambassador, and you can find me on X, I guess that's what it's called now, and pretty much any social network at the end of Daniel JC Afonso. Oh, in case you don't recognize me, I'm this person here. This one is my pair programming buddy. Also, I might have written something about something that we'll be seeing today, which is this book called State Management with React Query. I already spoiled it. I'm going to do a giveaway at the end of the talk, so stay tuned and pay attention, because hopefully some of the questions that we're going to have there will help you answer and get the book if you want it. Now, getting back to the talk. And here we're talking about states. We're talking about splitting states. We have client and we have server state. And each one of them represents different things. Each one of them represents different challenges. Some of you might be thinking, okay, but what's client state? What's server state? What does each one of them entitles? Let's start with client state. Client state is defined I like to define and split them in 3 different things, because there's 3 different ways to figure out if you have what's called client state. The first thing is it's local. This state exists in your application. It's there. It doesn't exist somewhere over the internet. That's a spoiler for the next topic. But it's a state that is contained in your application. This also means that it's synchronous. You don't need to wait to get it. Probably you call a function, you call a value, you have it directly. You don't have to wait to get this state. And another thing, if it exists in your application, then it's probably temporary. So if you refresh your page, then probably this state will be reset. And I think that's all that I have to say about client state, because that's definitely not the focus of this talk. The focus on this talk is server state. Now, what defines server state? I like to say, once again, it's 3 things. The first one is it's persisted remotely. It exists somewhere over the internet, somewhere out there, a database, who knows, this state is there. If it exists somewhere over the internet, then probably it means it's asynchronous, so you have to fetch it, probably do a data fetch request or something like that, and that's how you get this data. You have to ask for it and wait a bit until it shows up. And what does this mean? It means if it exists on the internet, there's no guarantees that it's up to date. It might mean that, well, I got this data. If someone else is also using it, someone else might change it. So if they change it, there's no guarantees that the moment that I got this value, I haven't lost. It hasn't been changed by someone else. And server state has a bunch of challenges. I'm just going to name a few. The first, anyone wants to try to give an idea of some challenges that we might have with this state? No one? Okay, I'll start with the first one, caching. That's the main one that we start seeing when we have to deal with server state. Oh, we have to implement caching, we want to get this data, but we probably want to save some money or try not to refetch this data, so what if we could cache it? That's the main challenge. Then we have stuff like deduping duplicated requests. For those of you who are not familiar with this term, let's imagine that you have 3 components being rendered, and these 3 components need the same data. What would probably traditionally happen is each one of these components triggers a data fetch request, and the 3 of them there are 3 requests fired, and you get the data for each one of them. When you're deduping duplicated requests, what happens is, when these 3 requests are fired, only one will end up going on the network. You're going to get your data, and this data is going to feed these 3 data sources. So that's pretty much canceling some requests and only getting your data from one point. Then you have other patterns. So if you're dealing with server state, with data that I already gave you a hint, there's no guarantees that it's up to date, you have to manage it. You have to understand on how do I make sure that the data that I have, it's still fresh, it's still something that's on the database. There might be stuff like, if we're doing caching, then we also have to deal with cache invalidation and a bunch of other patterns. And then we have some patterns that some of you might be familiar. So optimistic updates, paginated data, infinite scrolling, lazy loading. There's so many stuff here that's associated with server state that the challenges, they still continue. These are not the ones, they are the only ones. There are many of them. Now imagine that I, as a product manager or a developer, whatever, I got to you and said, okay, I want you to implement all these things by yourself in your product. You have to take some time and go ahead and implement it. This is probably how it would feel, right? You might be like, okay, I'm tired of it. I'm going to waste so much time implementing this and making sure it works with the solutions that I have. Then that's the other pain. So I was asked to do this 4 years ago. And we started thinking, okay, let's roll our own thing. Let's start implementing it. But this is one issue that I feel happens a lot. There's that paradigm of build versus adopt or buy or whatever. And we were starting to think about implementing all these things. But we started with caching, which is probably the biggest one. And after a week of trying to build our own stuff and doing the stuff that we have, we gave up. Because there's a lot of work that we have to do. There's a lot of challenges. Server state is very complex. And nowadays, the issue would be tying it, or back then, the issue would be tying it with all the solutions that we had. We had Redux. Yeah, some of you might say, okay, or Sagas or whatever. Yeah, they exist, but they are something that were built upon on something that already exists, which main focus was to focus on the client state. We needed something new. We needed something that would help us fix and deal with the server state challenges. And this was when 10-stack query, back then React Query, popped up into our lives. It had just been released, announced by this guy called Tanner Winsley at I think it was React Summit in 2019 or 2020. 2019, I think that was then. And we were hooked because, no pun intended, not pun intended, but we were hooked on it because it was something that seemed very, very simple to manage something that we were having so much hard time to implement. Now, before we get into 10-stack query and understand what it is, because that's going to be my focus throughout the rest of the talk, I'm going to focus on React Query, in case you haven't noticed so far. And we're going to learn a bit more on how it works and how we used it to solve some of the issues that we have. And hopefully by the end of this talk, you have some concepts that you can take home and apply it. Now, 10-stack query, or React Query, on how it was called when we started to know it, I like to define it as a protocol agnostic collection of hooks that you can use to fetch, cache, and update your server state. That's a definition, I guess. And since V4, it has been merged into this thing that's called 10-stack. So the creator of React Query back then, Tanner Winsley, since it's V4, I think I'm right on it, V4 has merged it into this super set of libraries called the 10-stack. So he has a bunch, which is pretty much the stack of things that he built. So you have 10-stack table, now 10-stack router, 10-stack query, and it is a high set of software that he uses and he builds to help developers. Going back to the React Query aspect of it, because one of the things, and it's funny because this discussion already happened today, when someone says, oh, I use React Query, and someone tells you, oh, now you have to change it for 10-stack query, now it's called 10-stack query. That was actually the first question I asked when they renamed it. I did a tweet on it. Probably would have been a good idea to put it here, but I did a tweet on it when it released. So now should I stop saying React Query? Should I only go for 10-stack query? Well, the answer is it depends on what you're using. So if you're using what it's called the React adapter for 10-stack query, you can still call it React Query. If you're using the Solid adapter, you can call it Solid Query. You can still call it whatever. This is an issue that doesn't matter a lot, but just to clear up some misconceptions that it has been. The superset is 10-stack query, and the adapters are the name of the framework. All the examples and the stuff that we'll be seeing here are focused on React Query, so let's go ahead and learn some stuff. Now, there's two fundamentals. There's two fundamentals that we need to grasp to understand on what and how should we use this library. The first thing is queries, and the second thing is mutations. Now, starting with queries are the things that allow you to, well, query for data, fetch for it. So typically, queries are associated with data fetching. On the other side, you have mutations. Mutations is when you want to go somewhere and change the data that you have there, create it or delete it. So if we're talking about or thinking about a CRUD application, then queries would be the read, and mutations would be the create, update, and delete. And you can use both of them with React Query and in different ways. And the pattern is different. So let's start with queries. The ways that you use queries is by using the use query hook. By the way, this is the part that I mentioned that the context might change a bit. If you're using view query, it will still be use query. But if you're using Svelte and Solid, the name changes for create query. So the fundamentals are still the same because at its essence, there's a main library called built upon it that feeds all these other ones. It just changes the naming that you use on each framework. So use query is responsible for fetching data, and there's only two things that you need to do to understand to deal with use query. The first one is the query key, and the second one is the query function. The query function is responsible for being the function where you fetch that data. The query key is responsible for identifying that data. How does this work? Well, so here we have our computer or React component, and this component will be using our useQuery instance. What happens is when this component renders, if we are assuming a default behavior, that hook will be responsible for fetching a data request. So what happens is our component renders, and we need our data. So we have the internet, and our hook will be responsible for fetching our data, calling a request to get the data, ask it somewhere from a data source, and getting it back. This part that we have here, and let's see if this works. Yeah, this part that we have here, it's associated with the query function. The query function is responsible for fetching and receiving your data. Now, on the other side, we have the query key. And the query key is super important. Sometimes people don't understand how powerful query keys are until they start working with it. Because query keys are responsible for doing one thing. And that is caching your data. Exactly. So query keys are responsible for being the identifier in the query cache that React Query has of the data that you just fetched. So hopefully now you start seeing a bit more of the value that they have. Now, I'll show you some things, but not on the next slide. The next slide here, I have some examples of query keys. By the way, query keys need to be arrays. If you have been using React Query previously, you could have whatever you wanted, but since V3, they have changed it to be only arrays, and now on V4, which is currently in beta, is being mandatory. So now query keys needs to be arrays. And I like to treat query keys as dependency arrays. Then you should always use them to identify all the dependencies of your queries. What do I mean by this? Let's once again try this thing out. This example that we have here we have an array with a string called users, page, and filters. This query key is representative of all the dependencies that I would need to build pagination. Why? Because here we have a string, which is generally a dummy identifier, a page, which is the current page that I'm getting, and some filters. What happens here is whenever I render something, imagine that page value is 0 and we have 0 filters. What happens is whenever our hook mounts and our component mounts and our hook renders, it's going to fetch data and cache it under users, 0, and probably an empty object, which is what this array is. Now, imagine that our user changes a page. Now he goes to page 1 or page 2. This value is going to change. So now we are not on the same cache instance. And so what will React Query do? Trigger an automatic request to fetch data and feed this cache. So this is why I like to say that query keys need to be treated as your dependencies arrays. They need to be the things that will identify and mostly relate to how your data is stored in your database, on your cache. There's another thing, but I'll show it to you in a bit. This code, it's a lot. Don't worry about understanding what's happening here, but this is an example of how query functions work. By the way, I mentioned that React Query or 10-stack query or whatever, it's protocol agnostic. This means that you can use whatever you want. You can use REST, you can use GraphQL. Heck, if you want, you can use SOAP. I don't care. As long as there's some promise inside of there that returns data, you can use whatever you want to fetch data. Here we have an example of using GraphQL. So on the top, let's just use this again. On the top, we have our query, and here we have what's called the query function. This is the function that's responsible for doing that promise and getting the data. And what do we do afterwards? We get this query function and we pass it to our hook. So now our useQuery instance has the query key and the query function. What will happen is once this function is triggered, it will return the data and be stored under the cache, under the array with the string posts on the first element. And this is pretty much how it works. Now, next part. Let me just close the example here. The next part, and this is why I like to even more put emphasis, that's the word, put emphasis on the query key aspect. Here we have a query key that on the first instance of the array we have an object with a property of query identifier and API name. The reason why I like to have this pattern is because your query keys can be injected in your query function. So what does this mean? It means that your query function in the first element, and I'm pointing, let me just put the laser, oh, spoilers. Let me put the laser so people at home can see it here. Here we have our query key. And because query keys can be injected into query functions by using something that it's called the query function context. And these query keys are injected here. Why is this important? Because then you can access it and use it. In this case, we are using it to customize the URL where we're going to be fetching data for. This is super powerful as well because now imagine that we had that pagination example. It would still work because now we would have our page here, whatever. We would fetch our data and return it. So this is why it's even more important to treat query keys as your dependencies arrays. Now, I just want to clear up some, I'm going to say bad habits that exist for people that already used React Query, and that is cache time and stale time. This is probably one of the two concepts that are most misunderstood when talking about React Query, and I'm going to explain both of them, and hopefully it will be clear for everyone here. And when you go use React Query, hopefully you will, it will be easy to understand. So let's start with the first one, cache time, or how is it's called in the new version, GC time. It's defined as the duration in milliseconds until the query data that it's inactive is garbage collected. This is the normal term. And probably you can start to see why there's some confusion, because when you see cache time, what does your brain think? Oh, it's the time that the data is going to be cached. That's partially true, because it's the time that the data is going to be cached after your query is no longer being used. So imagine that you're using a query in a component and then your component unmounts. That query is no longer being used. So this is when cache time comes into the loop. It tells React Query, hey, after this time has elapsed, then you can garbage collect this data. And you can see that this is why they have renamed it GC time recently. So now the pain disappears a bit and it's more clear what should be expected, because I can tell in the past 3-4 years of using this library, this is probably the most misconcepted term out there. And the second part is stale time. Well, stale time is also duration in milliseconds. That is used to define the time until your query is no longer considered fresh. Why is this important? It's important when we're talking about stuff like managing outdated data, because let's picture the following scenario. We fetch some data, we cache it, whatever, that's cool. But imagine that now immediately another component will render that needs the same data. What should be the behavior here? Well, the default behavior is React Query will go to the cache, serve its data back to the user, to the component in this case, and depending on the stale time, it will decide, should I trigger a new fetch data request or not? Let's imagine that you have a stale time of 1 minute. What will happen is, you just fetch data and immediately another component renders afterwards. If your stale time is 1 minute, then React Query will know, okay, I can serve the data from the cache, and I don't need to worry because I was programmatically told that this data is fresh. I know that this data is out there and is considered to be updated. By default, and I think they're thinking about this, changing this in the new version, but by default, this value is 0. What does this mean? It means that you fetch the data, you cache it, and if another component renders, React Query knows, okay, I'm going to serve you the data, but I'm going to automatically fetch it again so that we can have data that's up to date. And this is super important when you are dealing with stuff like managing outdated data. Then you have a couple of other scenarios for cache invalidation, but I have some code snippets that I want to show you in a bit. Before we go into the code, let's talk about mutations. The way that you can do mutations is by using the useMutation hook. If you're in React, Vue, it's also useMutation. Svelte and Solid, it's createMutation. The useMutation hook only needs one thing, which is the mutate function, which is the function that should be responsible for doing this mutation. And this function will receive some data. So let's once again get to this part here. Let's see if I can use it. As you can see here, we are expecting some user. We are expecting an object which probably is going to be some user data. The way this works is, well, we pass this query function to our useMutation hook, and we destructure something called mutate, because mutations don't happen automatically. We don't want them. We only want to call mutations whenever we have a need to execute them. So whenever we have the need to call mutation, we use the mutate function, and we pass it our object. In this case, it's going to be our name and our age. And this thing is going to be injected into the mutation function and be used, in this case, to do our post. That's pretty much the behavior on how mutations work in React Query. Now, I don't know how much time I still have left, but I want to show you some code before we go into the quiz. So here we have an application, which is a note-taking app where you can only add notes. You cannot do anything else. It's just responsible for adding notes and displaying them to the user. So let's just clear this up. If I go here and say, hello, I add a note, this thing should work. Let's see if I can zoom this a bit more. No, I don't want to zoom here. I want to zoom here. And this thing would happen here. Let's see what happens. So this part doesn't matter here. We added note. When we click and add, there was a mutation that was responsible for, in this case, doing a post and sending our data to the internet somewhere. But automatically, what also happened after that mutation was finished was there's a GET request here. Automatically, what happened was there was some cache invalidation that went out there and says, okay, now that we created a mutation, we need to update our data to show this to our users. So what's happening here is we're doing already cache invalidation despite also along with the data fetching. So let's see how this thing works and behaves before we continue. What do we have here? Can you read it? Okay, need more zoom. Bit more? Let's do it. Still good, bit more? Because in my computer, it's very big, but there it seems to be very small. Okay, hopefully this way you can all see it. Let's put this full screen for a bit. Okay, so here we have the normal things we're used to. We have a use state, so we know that there's going to be some client state in our application. Then from 10-stack query, we are destructuring a use query. So we already know that there's going to be some querying in your application. A use mutation to perform mutation in something called use query client. What's query client? Stay tuned, because I'll tell you in a couple of seconds. And we have a const called API A that apparently has a string. Okay, might be relevant for something. And we have a fetch data function. So looking at these, I will assume, okay, this is probably a query function because I'm going to be fetching some data. And this function is receiving a query key. So I know that there's going to be a query function context working at here. And I use this query key to get an API name to customize the fetch request that I'm going to get to my endpoint. And then after I get the data, I validate if it was okay. If not, if it's okay, I return it. And here, I have a create note function. So I see create, so I assume there's going to be my mutate function. And this function is receiving a note. What happens here is I do a post request to endpoint, which has my API hey, which is this route here. And I send my data. Okay, standard mutation, standard data fetching. Let's look at our component working. Here we have, once again, the use query client. What does this work for? We'll see it in a bit, don't worry. We have our use state, which has a note, a set note. Okay, what is this supposed to be doing? Well, if we go back here, we have a form, we have an input. Our input has a note. Whenever we change this note, we update our state. And then when we click on the button, we submit it, which will probably be responsible for doing our mutation. As you can see, there's a mutate being triggered. So it's going to get our data and trigger our mutation. Going to the React query part, because this is the fun part here. So let's start with the use query. A use query hook has a query key, which has our, on the query key array, on the first element, we have our query identifier and our API. And this API is going to receive the API A. So the thing that's going to be injected here, it's going to be the value that we're passing there because of the query function context. And then we have our query function. Standard behavior, whenever we get the data, we're going to have it here, that we can use it. And there's something here called the is fetching. So the is fetching is network status. So there's a difference. We can talk about it afterwards if you are interested into these things. But pretty much the gist of this function, this value is, it's a Boolean indicator to tell you if there's a data fetch request happening right now. The way that I use this is going to my div. If I'm fetching, I'm showing a fetching indicator. If I'm not fetching, then I'm going to assume that I have the data, so I map over it and display it. Pretty standard behavior. Now going into the mutations. Going into mutations, we have our use mutation hook, or create note mutation function that we are passing. We already seen it. It's this one here. That expects to receive a note and then does a post. And let's hide this for a bit. And yeah, that's the standard behavior. Whenever we submit, we pass it a note. Mutation successful. Amazing. Now, what will happen here? We're going to do a mutation, but we are still displaying our data. And if you remember when you saw this example, after I did a submit, my data was refetching. This is because I'm doing cache invalidation or query invalidation. What happens here is when we're doing a mutation, we know that just because we changed the data source, this data is no longer going to be fresh. We know that we changed this data. So we need to tell React Query, hey, look, the data that you have right now has changed. And this is where query invalidation comes into the mix. How do we do this? Well, it's thanks to this hook here this callback called the onSuccess. This is something that you can pass to your mutation hook that allows you to do something. And in this case, I'm doing query client invalidate queries. What is the query client? Well, the query client is pretty much, we can talk about it as the context aspect of it, which is something that it exists on the top level that's wrapping your component, and it's used to hold your query cache. So when you see the query client, you know, okay, this is where my query cache is. So if this is where my query cache is, then I can use it to, well, to name a few, prefetch data if I need it. I don't have the example here, but you can do it. You can invalidate queries, and there's a bunch of other patterns that you can do. In this scenario, what's happening here is I'm going to my query client and I'm telling React Query, hey, the query that you have cached under this query key here is stale. It's no longer fresh. And when this happens, React Query knows, okay, because my query data is no longer fresh, I need to refetch it. And then, as you can see, or you could see it immediately, when I did the post, when the post was successful, it immediately triggered a new request, so we could feed our store. Now, because I don't have a lot of time, and I want to go to the Slido example, you can ask me, and I'll post on Twitter and LinkedIn the repository, because this repository is open for everyone. This is the repository that has all the snippets from this book. And there's a bunch of stuff that you can do here. There's a lot of patterns. You can do stuff like optimistic updates, you can do multiple queries, you can do infinite queries, pagination. And one question that I've been asked is, but now with server-side rendering and whatsoever, should I still use React Query? The answer is, depends, but you can still use it. Because in most scenarios when you server-side render stuff, there's going to be some client stuff happening afterwards. So you can still use React Query to integrate with your server-side rendering. So there's also some examples here of using Remix and Next here on how to use React Query to do those patterns. So now, to wrap up this part and go to the quiz. We saw some code, and as you can see, React Query allows you to do a bunch of stuff. In the beginning, I talked about caching. There's caching. There's deduping duplicated requests. We didn't see it, but it works. Paginated data, managing outdated data, optimistic updates, infinite scrolling, lazy loading, scroll restoration, offline support, data prefetching, and many other stuff. React Query has definitely been one of the things that probably, when I know that I'm going to have data fetching in my application, which is pretty much everything, I know that I will install it. So hopefully, I have given you some overview and convinced some of you to try it out. So yeah, to wrap up, yeah, this is the last slide, so I'm not going to show more slides. I have a quiz to give away this copy of the book. Oh, just a disclaimer, if the giveaway is going to be a physical book, so for the people that are watching online, I'm sorry, it's exclusive for people that are here, but if you want to participate, you can still participate. So the winner will get this copy of the book. So I'm going to ask you to join Slido, and there's going to be 7 questions, so it should be fast. Let me hide for a bit here, just to give you time to scan it. And it's going to open the page. I'm just going to now prepare, and I'm going to ask you to join, add your name there, and start participating. Let's just start seeing people showing up. Okay, so there's 3 people here, 4. I'm just going to give you a bit. Okay, there's 14 people. I'm going to give you 10 more seconds, and then we'll start. When you're on stage, 10 seconds look like 50 minutes, just by the way. Okay, so let's start the quiz. So there's going to be 7 questions and only 1 winner. So have fun, hopefully. So the first question, according to this talk, how should you split your global state? Client state and server state, UI state and server state, user state and server state, or synchronous state and asynchronous state? Let's see you paid attention to the first couple of minutes of the talk. 4 seconds to go, 3 seconds to go. And 83% gone to client state and server state, and 83% got it right. Let's see who's on top. So Toma, is this how I pronounce the name? Is currently winner? Okay, so he's on top right now. Congratulations. Let's see if you can still stay here. Next question, who created React Query? Was it Ryan Carniato, Tanner Linsley, Kenzie Dodds, or Bruce Wayne? Let's see, 10 seconds to go. Let's see this answer. This was mentioned during the talk. I think I only mentioned it twice, but it was mentioned. Let's see how many of you got it right. Okay, 83% got it right. It was Tanner Winsley. Last time I did this quiz, more people put Ryan Carniato than Tanner, and it was fun because then Ryan went ahead and said, I created React Query. Next question. Oh, now we have Vidran. Vidran, I hope. Okay, you're winning right now. Let's see if you keep here. Next question. Where is the next CityJS event? So let's see if you have been checking the event list for CityJS. Is it New Delhi, Berlin, Nigeria, or London? Let's see. Let's check these answers. 5 seconds to go. 25 people answered. Some of you were trying to Google it, probably. Okay, 60% went to Berlin, and only 20% got it right. Next week, there's going to be CityJS in New Delhi. Next week. I hope it's next week. It's next week. Aries is there somewhere. Okay, doesn't matter right now, but it's New Delhi next week or the week after. What are the main hooks of React Query? Is it use query and use mutate? Is it use queries and use mutation? Is it use query and use mutation? Is it use queries and use mutate? Let's see who gets it right. 17 people have already answered this. 22, going the countdown. Let's see. Okay, 69%, use query and use mutation. You got it right. Let's see who's on top. Dusika? I'm sorry if I butcher your names, I'm terrible. Okay, you're on top right now. Let's see, 4 out of 4, congratulations. Let's see if you continue this way. Can I use SOAP with React Query? Let's see, yes or no? Let's check. 10 seconds, 24. Okay, 3 people to go. 25. And going for the answer. Let's see who paid attention. Okay, 96% got it right. Yes, you can. It's protocol agnostic. You can use whatever you want in your query function as long as there's a promise there. So we still have the same winner, 5 out of 5. Let's continue. 2 questions to go. Where's the next Halfstack event? London, Tel Aviv, Phoenix, or Vienna? Let's see. Oh, hide. Let's see. Spoilers. Oh, well. Let's see. Just need to find people with shirts. Specific type of shirt. Exactly. Still, only 62% got it right. It's Vienna. There's a lot of people here with the shirts. See, as you can see, it's already announced here. Oh, and by the way, who has a ticket to go? Oh, you still have an opportunity. Okay. And going for the last question. I forgot to show the leaderboard, just for the suspense. What is cache time? The time your query data will be cached, the time until an active query data is garbage collected, the time your data is considered fresh, and the time until an active query data is garbage collected. Let's see who gets the last question right and gets the book. Okay. Okay, 60% of you got it right. It's the time until an inactive query data is garbage collector. Therefore, the renaming for GC time. So let's see the winner. Okay, so who's the winner? Oh, congratulations, you just got yourself a copy. Okay, so as you can see, the hardest question is where is the next CityJS event? So now you know it's New Delhi. So yeah, with that, thank you so much for having it. It has been a pleasure, and I'm going to hand it over for Dylan to pass for our next speaker. Thank you, everyone.